13.3, evaluate trig functions.
Is this going to hurt me if I try writing down these problems and understanding them without having had the notes done?
No.
Okay.
You'll be fine.
You also have to
The next section, yes, probably.
Are the notes 2 pages long?
Yeah,
Yeah.
1
That's how big mine is.
3.
You're way too
I'm
big.
making you right.
Like pretty big.
I write on the front thing here. You have tiny paper though.
All right, the first one say use the point on the given terminals or on the terminal side of the angle theta in standard position to evaluate the 6 trig functions of theta. So they give us the point 5, -12. Okay, so the way we start out with a problem like this is we basically plot this point. Now, I'm not saying to get out graph paper and go to 5 and go to -12. I'm not saying to do that. What is happening? Who's calling me? Okay. So you want to just put it in the right quadrant. So what quadrant is that point in?
Positive, negative.
So what's
Left.
the 4?
4. It's down here. Now, the triangle always gets drawn touching the x-axis.
Absolutely. Wait. X-axis.
So yeah, you always go to the closest x.
And does it always touch origin as well? Like, the
Yes.
points? Okay.
That's the
The angle is always at the origin.
Right. Okay.
because the
Standard position.
the terminal line goes through.
All right, so this side is 5. This is -12. Now, hypotenuse can never be negative. Okay, just something to note there. So, now I need to find the hypotenuse side.
Sine.
13.
Why?
Because 5 squared plus 144 is 169. 169 square root is 13.
Thought you were gonna tell me because it was a Pythagorean triple, and I was gonna get really excited.
It's a Pythagorean triple, man.
I got the answer. Why can't you just be happy with that?
No, I was. I just meant I was gonna be even more excited if you remembered that it was a Pythagorean triple, because I know good and well you would have learned that in geometry. Most classes can't tell me that, but that is a Pythagorean triple.
Can we go over what a Pythagorean triple is again?
It's basically just like numbers that, like, none of them are gonna have square roots or anything. They're all like perfect squares.
Oh yeah.
What? Wait, so if we had 2 square root of 3 there, would that be a triple?
No.
But 12, wait, is 12 2 square root of 3? No, it isn't. Wait, yes it is. No, wait,
That's
That
root
can't
12.
be. That would be the square root of 12.
3, 2, 2.
We're not rooting 12.
All right, so now, just like what we did in section 1, sine of theta, cosine theta.
Oh, not the mean lines.
Oh, I thought she was saying.
This actually was super impressive yesterday. It was literally solving pre-cal problems.
Wow.
Is that good or bad?
That's alright, we can do that too.
We could barely do this.
It was solving trig word problems. It was pretty impressive.
Oh, wow. What is this track you're using?
It's the Notes app on the iPad.
Alright, I'm gonna start doing math over there.
Sometimes mine acts like it wants to solve like 7 + 8, but nothing else. Just like super simple math. I'm like, where is this gonna help
Yeah,
me?
yesterday, hold on, let me see if I'll turn it back on and show you. It was doing stuff like this. So we would do like the tangent, or hold on. It was like 35 tangent of 20 degrees.
That's not part of this problem, though.
No.
Oh
It
my
is
goodness!
solved.
That's in your handwriting too.
That
It has
handwriting
terrible
sucks.
handwriting.
Man.
This doesn't have hands.
Anyways,
That's
it
okay.
just, yesterday I did the first problem. I was like, humor me. So I like clicked on it and it did it. And I was
Did it
like,
tell you what
whoa.
to-
And if you don't put
What's that
the,
last number?
a 9. If you don't put the degree symbol, it assumes it's radians.
Wow.
I still don't. What is a radian?
There's a difference.
Oh, geez.
I still haven't
Oh
known
no.
what a degree is.
Separate.
We went over this.
Radians is pi over 2.
Anyways, it's just cool, but it doesn't work for everything, and it still can't solve calculus. So until it can do that, I don't care about it. All right, what's the sine of theta?
Sine of theta
Sine is so opposite of a hypotenuse, which is negative 12 over 13.
Cosine?
Cosine so
Adjacent
of a hypotenuse, which is 5 over 13.
Thought I turned this back on.
So capital opposite over adjacent, which
Negative
is
12
negative 12
over
over 5.
Cosecant?
13 over negative
13
12.
over negative 12.
Secant?
13 over 5.
Cotangent?
5 over negative 12. Mine only got one right.
Now,
I do
the
that?
most common thing that people get wrong is that it's not touching the x-axis and they don't use the angle that's at the origin.
No.
I
Okay?
thought it is.
Sure.
Shepherd.
That's why I said people get wrong because they
Oh.
don't do that. Okay? So, big things. Make sure it always touches the x-axis, not the y. It never touches the y, only the x.
Only
Okay? And it's got to be at the origin. We're not using this angle up here. We're not using this one over here. It's always the one at the origin. If you do that, you shouldn't have a problem getting these problems right.
Always use the standard.
All right. -6, 9.
6.
-6, 9.
My block blast school, except not negative.
And negative block plus is crazy.
Well, I've given up on block.
Cleese is still like 5,000.
I need to bring them up.
No, I watched her play like at one of the games, and she'll just like not see it. I don't know.
It's in
All right.
quadrant 2.
Not smart.
Quadrant 2.
Yes, it's up here.
That
It's
means
got to touch the x-axis, not the y-axis, which means it's going to be
it
weird.
has to go down. Okay, this is the
All right. So -6 is on the x.
Oh, it's
9
it
is
another
here on the
Pythagorean?
y.
Is it a
Pythagorean triple.
No, it's not.
It's not a Pythagorean
6 times
triple.
6 is 36,
36
plus
times
81 is
127,
127, which is 13.
127 squared.
No.
I mean square root.
You're saying
Is
It's
that
not
prime?
127.
Oh, dang it, Shepherd.
Is it prime?
It's 111. What? 11
Wait, 6 times 6 is not 63.
It's 11.7.
What is 6 times 6?
It's
36.
11.7.
36.
So
not
117.
117. That's what I
11.7.
said.
That's what I got, and I changed my answer because y'all said something different.
It's 11.7.
Now, can this be broken down?
Hopefully
No.
not.
No,
It
'cause I
can.
don't want it to.
It can. It's divisible by 3.
I was about to say
No,
that.
because yes, it is.
Yes.
Because
No, it
1 plus
is.
1
1
plus
plus
7
7
is
is
9. Which means that to get 100, you have to have 30, which is 90, which is plus 12, which is 112 plus 5, 115, 5. It's going to be 97.
No, it's 3 square root 13.
Yeah.
She already wrote it.
All right, everybody tracks how we're getting the hypotenuse, right? Because I'm not actually writing it.
Yeah.
It's just the a
We're
squared.
doing the Pythagorean theorem. So the square root of the two numbers that were given squared added together, which is giving us that. Then I divided by 3. They gave me 39, divided by 3 again. So I pulled out a 3 and I was left with 13. All right, so 3 root 13.
Sine so opposite of a hypotenuse. You can't do that.
Costco.
Hey.
What?
Yes, you take off point.
I was just saying Costco.
He just wants some pizza.
Oh, I thought you said we just lost the pizza. I was like, we're going to get pizza.
I mean, yes, I do get
Are we
pizza for
almost
the
there?
people that joined me off of Theta, but
When do the points for the cookie points reset? At the end of the
when you
year?
get 10,
Dang it.
We're
When do
not
we
there
sign
yet.
up for Me Alpha?
How are we
Huh?
only at
When do we sign
4?
up for Me Alpha?
well, I had it on the board a while back, and I told people to tell me if they wanted to do it or not.
I'm
Danny,
pretty
you
sure
don't
you
we
told
told,
her.
right?
Yes.
I'll go back and look at some point and tell you
I
everybody.
would like to
I'm
do
gonna
it.
give another opportunity for people
Don't
to do
give
it
you
if
an
they
extra
want to.
minute.
Do you get
And then
I
I'm
love
probably
it.
gonna send the parents a message because last year I had some parents who were like, "Why did my kid not get in?" And I was like, "Cause your kid didn't tell me they wanted to. I told them it was $10, and they said no, I don't want to do it."
Do you get a complimentary headband?
No,
That's
the
science.
Oh man. Yeah, I think I'll do it.
That was
I think
We get pizza.
anyway.
Anyways, okay, sine of theta.
Is going to be opposite over hypotenuse, which is 9 over 3 over 13, but you have to multiply each side by square root of 13, so it's...
Well, how about I also reduce?
Yeah.
Why did you just fall out of your mouth?
So it's 3 square root of 3 over 3. So it's square root of 3.
Square root of 13.
So it would just be square root of 3.
Over 13.
Because,
No, you're wrong.
Wait. Oh, I forgot about 3.
What
What
would
about
happen if we
13?
just all revolted and decided that keeping the radicals on the bottom is okay? Like, would it
We
really
just all
change-
revolted.
It makes it
Then
easier.
I mark it all wrong, and you don't do
what
well.
if you were
If
in on
you
it?
were part of everyone, would it
Then
really
when you
change?
get to the AP exam next year, you will get it wrong.
But if everyone in the world decided that
Calculators
it was
can't make
okay
that
for it to be on the bottom, then
The
it would be
calculators have
okay. It
feelings
doesn't
every time we
change
type
the
on
Why
math.
don't we just do the math so we can get it over with?
Okay.
What if we just don't have to do the math in the first place to get a bad grade? and then-
Cosine theta is what?
They can't put that.
Negative 2 square root 13 over 13.
Negative
Where did you get 2?
He's just going straight to the answer, which is fine. It was negative 6 over 3 root 13. 3 and 6 reduce, so I get negative 2 root 13 over 13.
9 over 6.
9?
Negative 6. Oh my
Tangent of theta.
Tangent, TOA, opposite over adjacent, which is 9
9
over
over
negative
-3,
6, which is positive 2.
Negative 3 over 2.
You were so off.
Now, remember, when we have ones with radicals, I would use this original thing when you're flipping them to do the other so that you're not having to rationalize and reduce all over again. So what's cosecant?
This is
Square
square
root
root
of
of 13 over 3.
Yep. Secant.
3 square root of 13 over negative 6. Wait,
No,
that
it
could be-
isn't.
root 13 over
3.
2.
So I would use, I'll reiterate, reiterate's not the right word. I'll explain slightly differently. I would use the original thing, but if you've reduced a number like the 6 and the 3, I would just use the reduced form so that you're not having to do any more reducing or anything over here.
Absolutely.
So 2 over negative.
I think I'm just going to do the work, like having to reduce again, because this is really hard.
You'll get tired of that
I
eventually.
really love
I'm tired of it right now.
on the cot at Costco.
You slept on a cot at Costco?
Wow.
I was on
What'd
it.
you say?
I was on
You
it.
slept on a cot at
No.
Costco.
I slept on a tanning cot at Costco.
That sounds like a
Right.
sin.
What?
Cause
10, 5, negative root 11.
Ew, why is that in there?
you don't like that.
All right, where's this one?
5, 1, 2, 3, 4, 5, negative. Quadrant 4.
Wow.
Looked really disappointed when I said that.
Because you went 1, 2, 3, 4, 5, so I thought you were going to tell me quadrant 5.
No, I was like counting.
And I was like, please don't.
Negative square root of 11.
25 plus 11 is 36. Oh my gosh, the hypotenuse is 6.
Ow.
Because
Wow.
square root of 11 times 11 is 2 is plus 5 is 36.
What?
Negative. Shepherd.
Because it's 5 squared is 25, 11, negative 11 squared is 11, and then you add those together and you get 6.
You add them together, you get 36, which is square root of 6.
Yeah, but I'm just too fast, so I didn't say
So
that.
the only difference between this and the first section is now we have the triangles in a graph.
Yes, you have to draw them, whereas before, I mean, you had to draw them before, but they were giving you numbers and you just made a triangle however you felt like. Now it has to go in a specific spot.
Yes. Alright. Sine.
That's just the first section of that.
Sine theta.
Yeah.
Cosine theta. Tangent theta.
I don't know, but it's really not
Oh,
that bad.
you said a really fun word in the notes. It was like super theta.
created
And it's like a.
trigonometry?
It's
Whoa.
A theta sign.
Theta problem.
What?
Wow.
Whoa!
Hello?
It's Optimus Prime.
Why did it do that?
I don't know.
She's losing her powers.
Decided it was, I don't know. All right, sine theta.
Opposite over hypotenuse, which is negative 11 over 6.
Root.
Oh, well, the negative 11 squared. I mean, what is that
Negative
called?
root 11 over
Square
6.
root. Negative root 11 over 6 cosine.
5, 6, 5 over 6.
Tangent.
Opposite. Oh, negative 11 over
Root 11.
Oh my goodness.
Over 5.
Oh, now we have to do the thing.
Now, if you want to go straight to the rationalizing when you flip them, if you feel like you can do that, you're welcome to. I will write them flipped and then rationalize just so that we see it, but you'd be able to go straight to it. What's cosecant?
Negative 6 square root 11 over 11.
6,
6, 7.
Secant.
5, 6,
6, 6.
Cotangent.
5
root
root
square root
over
11 over 11.
I just said 11 like 13 times.
Yeah, there was a lot of 11s in there. I was just inferring what y'all were saying.
And you just 11?
I was just like 11 over
11.
Because I wrote it down. And I just,
Yes, I went.
So I would say 2 if I got it wrong.
Mine 11.
All right, quadrantial angles.
Tarantula angle.
Tarantula.
That's what I just said.
I was repeating it.
Oh, I thought you were correcting me.
Quadrantula.
Quadrantula. What?
Evaluate the 6 trig functions of theta.
Sound like drag.
12. Theta equals 0 degrees.
Ew. You can't do that. That's a line.
All right, so just to look at the graph, since that's kind of what we've been doing here, that means that that falls right here.
I was right. It's a line.
Really?
Now, r squared, which is your hypotenuse, is equal to x squared plus y squared. So x in this case is 1. We're going off the unit circle. Y is 0. So this is r squared equals 1 plus 0. So r is equal to 1. Okay, again, hypotenuse can't be negative, so that's why we're not doing plus or minus on this. So, I don't remember if this was in your notes or not, but sine is y over r, cosine is x over r, and tangent is y over x. Now, I'm going to tell you, typically I won't do literally any of this work that I just wrote down, aside from the little graph, because once you see one of them, you're going to be like, why did I do all of that? Because they're super easy. All right, so sine of theta, cosine theta, tangent theta. We're doing all 6 trig functions. I'm going to go ahead and write these down. All right, so sine of theta is y over r, which is 0 over 1, which is
1. No, undefined.
0 divided by 1 is
0.
0.
Oh. I thought we were doing the CSE.
Cosine is x over r, which is 1 over 1, which is just 1. Tangent is y over x. Y is 0, x is 1, so 0 over 1 is 0. See if we were going to get it that time. Cosecant is
Undefined.
flipped, so 1 over 0, which is undefined. Secant would still just be 1. Cotangent, 1 over 0, which is undefined. So all the quadrantial angles occur on an axis. Okay, so basically they're all going to be some combination of what I just wrote. That's why I said you don't really need to write down everything that I just did. Okay. Now, for some reason, they do that the odd ones are radians and the even ones are degrees, so I'm going to just make one up here. 5 pi over 2. So same thing, but we're using radians this time. So I've got my little graph. All right, now 5 pi over 2 is more than 1 whole time around because 1 whole time around is 2 pi. So this is 1 pi, 2 pi, or well, not 1 pi, hold on.
1
Pi over 2, pi, 3 pi over 2, 4 pi over 2, 5 pi over 2. So this is 5 pi over 2 here, straight up and down.
You don't get it?
No.
When we were
Because
drawing angles the other day.
so Shepherd,
Same
every
thing.
time it's 1, you go a quarter of the circle. Every time it's
What do you mean every time it's 1?
like, okay.
See that 5 right there?
Yeah.
Pi.
That's 1.
Shepherd.
That's a 5.
Shepherd.
No, I'm just saying, each
Shepherd.
of those ones is a 5.
That's Anthony Edwards.
Shepherd. Pi over 2 is like half.
Pi
the
over 2
circle.
is here, so it's half.
Yeah.
So that means I go up
That's 1/4, and
One,
then it's 5 times. So
2,
you're just going
3,
1, 2,
4,
3, 4,
5.
5, which you just did.
which is pi over 2.
Yes, 5
Yes.
pi.
This is equivalent to pi over 2.
So 5.
It's a
doesn't
coterminal
exist.
angle,
Oh, I remember that you added minus 360.
or 2 pi. Alright, so what I typically will do as far as work is I'll write out x, y, and r, obviously, if there is one. Well, there will be, but anyways. X is 0, y is 1, so r has to be 1. So that's typically all the work that I do once I know what a quadrangle angle is, because you don't really need anything else. So sine is y over r. So what do I get when I do that? 1. Cosine is x over r. What do I get when I do that?
0.
Tangent y over x.
Undefined.
Undefined. Cosecant.
1.
Secant.
Undefined.
Cotangent.
0.
0. We okay on that?
So R.
It's just like weird. I don't know. I don't really understand
Sine
the
is
point
x.
of those, to be honest, but
When we're finding x, y, and r, those are just like the Pythagorean theorems, like x is a, y is b, and r is c.
yes. But I get the 0 and the 1 for x and y from the unit circle. Because at this point, x is 0, y is 1.
Oh, because it says it here. Okay.
Yes.
So if it was 4 pi over 2, it would our x and y would be 1 and 0.
4 pi over 2 would just be 2 pi, so x would be 1 and y would be 0, yes.
Oh, the unit circle works.
I did teach it for a reason.
Can I get another one because I messed up on mine? I'm just gonna rewrite it.
Yeah, I'll
funny.
just remind me when we're done. I'll give you another one.
Yeah, it is.
I just need another.
All right.
Colors now.
We got the big quiz tomorrow about it.
Not ready for that, please.
Well, the good news is if you bomb it, it only stays in grade link for 2 days.
I should get rid of that grade just to scare my mom. And then not tell her.
And then you like lose your tennis shoes or something.
Oh, I'll tell her the truth if she tries to do that.
Wait, so why are we?
Because I don't put it in that it's a practice quiz. I just put it in as unit circle
I'll tell her
quiz.
if she tries to take something.
Wait, so why are we-
Because some people need a reality check of,
Can
oh, I
you
need to study.
leave a note on his grade saying take his shoes.
Not, because she will.
I know, and it would be really funny for 48 hours for you to not have your shoes.
I would instantly tell her it was a practice.
That
That'll be the first
She
word.
give us a question.
beat Ryan and said take his shoes.
And then she'll message me and I'll just casually forget to respond and tell her. I'm just kidding. I wouldn't do that to you.
My mom needs to stop like getting no people at this school.
Alright, we're finding reference angles now.
The reference. Isn't that in the song?
It says to sketch the angle, then find its reference angle. So these were those crazy things like such and such minus 180 or 360 minus theta, those things that you had. That's what these
I
are.
don't see it.
Well, you don't have your notes, so that would be why.
I thought you meant on the unit circle.
This is this part where you might be a little confused, but everyone's typically confused even with their notes, so you should definitely still write it down though. All right, negative 100 degrees. So I'm gonna sketch this angle. So This is negative, so that means I'm going the opposite direction, so I'm going down here. This puts me at 90, so I need to go 10 degrees past that. So basically this angle is right here.
So that's 90 when it's on minus 10. Okay. I understand.
So this is where people get confused. This angle here is theta.
So it's 260.
This angle here is theta prime. Yes.
Huh? Why
Wait,
did the
what?
Thor?
So then what's the blue?
The blue is the initial angle I was given, the negative
Oh,
100.
okay. And then from that.
All right, so when something falls in quadrant 3 for degrees, it is theta prime is equal to theta minus 180. But theta has to be positive for these to work. Okay, that's why we need the positive theta. That's what's written in green. Okay, so yes, if we went all the way around, this is 270 degrees, but I'm 10 degrees back, so this is 260 degrees. So theta prime equals what?
Wait, so theta prime.
80.
80 degrees.
So what was the question asking again?
Fine.
It said to sketch the angle and find its reference angle.
Okay, so theta prime is the reference angle.
Yeah.
Are you just writing a little like tick next to the theta?
Yeah.
Like an
It's
apostrophe.
a prime is an apostrophe.
Oh, exactly. Oh.
Wait, I don't
Wow.
get it. Oh.
Because when you turn it counterclockwise in Rubik's cubes, it's prime.
I'm not that one. I like it. Then they got hard, so I did that.
All right, 18 is 320 degrees.
I know how to solve one of them.
All
Can
right.
you solve a 2 by 2?
It's positive.
No, I don't know how to solve that one.
We're not
You
talking
just
about
take away the
Rubik's
steps
cubes
from
here.
3.
90, 180.
My graph was tilted.
All right, so I know that in this case I'm going around.
Up. Because it's
That's
positive.
270, so I need to go 50 past that.
You just do.
So there's my angle.
And then theta prime is the closest to the x. So
That was a really good circle.
no.
I didn't even fix
Does
that
theta
one.
prime also have to be positive?
Do
Or is
what?
it- Does theta prime also have to be positive?
Yes, because it's a reference angle.
Okay.
So this is in here, theta prime. Now, in quadrant 4, the formula in degrees is theta prime is equal to 360 minus theta. So theta was 320 for this one. So we've got 360 minus 320. So theta prime is 40 degrees.
And this is just something we have to memorize. Like which
The
quadrant?
formulas.
Yeah, for which
Yeah.
quadrant?
So this
Now-
stuff is gonna be really hard.
In theory, they should logically make sense. Your reference angle is the distance from the x-axis.
I still don't get it.
Wait, so you
So
can-
from the x-axis, this angle is 40 degrees.
Yes.
Oh, I get it now.
On this one, this angle here was 80 degrees.
Oh.
Okay? They're always going to be positive. It's a little easier, in my opinion, with degrees than it is with radians. I mean, obviously radians you can do too, but
So
I just
so
think
the
it's easier
angle
to
from
think
the
about.
Y-axis is 50.
no, it's just theta prime from the whatever what term.
Yes, but that's not the
terminal line
reference.
to the x. Okay.
All right, so 1 in radians. Negative 5 pi over 6. So that's over here.
Oh, no.
Yeah, you have to get it over.
So this is theta. or this is the theta that they give me, but my positive theta is what I need. So how many is it around here in positive?
2,
How did you got that?
1, 2, 3.
How'd you get the line?
Yeah, how'd you get from? Cause
It's 7.
Oh, the unit circle?
7 pi over 6. Down here, 5, -5 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. If I was working backwards, I'm imagining my lines on my unit circle.
it's negative. So.
I know that from here to here is pi, so that would be 6 pi over 6, so I basically just went back 1.
So is the green?
But that's
theta
only
pi?
Is there a 5 pi over 6 on the unit circle?
Yeah, it's at 150.
Wait.
But it's not negative.
Unit circle. Oh, I found it.
So,
So-
which is theta, the green or the blue?
So blue is the initial theta,
Okay.
but that's a negative number. When I use the formulas, I've got to have the positive one.
Oh.
Everything in these formulas has to be positive.
And that's 7 pi.
7 pi over 6, yep.
So
So in quadrant 3, the formula is theta minus 180, or theta minus pi. So theta prime equals theta minus pi. So 7 pi over 6 minus, I'm going to rewrite this as 6 pi over 6. Okay, so I have a common denominator. So that is pi over 6. Which again makes sense. All the way around on half of it is pi. If I was at 5 pi over 6, that makes sense that there's only 1 pi over 6 left over. So the formulas, the reason like I keep looking back is because I want like the formulas themselves are weird. I just see the reference angle and I don't even think about the formula. Okay? So sometimes you don't even really need the formula. You more need it if it's like a weird set of numbers.
I'm so confused about how we got 7 pi over 6. Where did that come from?
It's the positive angle. So 2 pi minus 5 pi over 6 is 7 pi over 6.
2 pi over.
Wait, 2 pi over. So it's just the common.
Okay, so on this.
It's a coterminal angle.
Terminal angle of
It's a
what?
negative 5 pi over 6. If I add 2 pi, I get 7 pi over 6.
Wouldn't you get? Never mind.
It's 12 pi over 6 if you like fix it.
I don't know.
This is so hard.
Wait,
This algebra.
Why did we sign up for this?
could you show us the coterminal process for 20?
Yeah, can we just do that whole problem again?
Yeah.
May you please?
Negative 5 pi over 6 plus 2 pi, which is negative 5 pi over 6 plus 12 pi over 6, 7 pi over 6. Boom.
Okay, and then where did the 2 pi come from?
That's how you get
That's
coterminal.
Coterminal angles.
For a radius. Okay, okay. I'm not
Oh,
gonna write
because
that
then
down.
the common denominator, that's 6.
Yeah, that's what got me.
Okay,
So
yeah,
when we have the angles, you add or minus 360, but if you have like the weird radians, you do 2 pi.
yeah, because 2 pi is the full round circle.
So why didn't we minus 2 pi?
Because I need the positive number.
Okay,
Yeah, not the negative.
Numbers all have to be positive when we're doing this stuff.
all right.
You don't need a little more sense.
All right, 22. 15 pi over 4. Now, I could count this all the way around multiple times if I wanted to, or I could find the coterminal angle first, and that's what I would recommend doing
2 pi.
because
Negative
this
2
is
pi.
more than 2 pi. So I'm going to subtract 8 pi over 4, which is 2 pi, which gives me 7 pi over 4. So now when I graph this or like draw out the sketching of this angle, I'm going to just sketch 7 pi over 4. I'm not going to sketch the whole thing. So 7 pi over 4 is almost all the way around. It's going to land over here.
So 1, 2, 3, 4,
Oh yeah, because
5,
it's
6,
almost
7.
2 pi, and if 2 pi is like a full circle, and then that's where we get our gradient.
7.
Yes.
So we went around 1, 2, 3, 4, 5, 6, 7.
Yeah.
7 times, and then how did you know where to put the angle pointing out?
Because Shepard, if it was
Because I know what my unit circle looks like.
Oh, okay.
and if
So
it
it
was
is coming out at 315.
if it was 8 pi over 4, it would have been the full circle. So it's just like a little bit there.
So this is theta. It's already positive, so I don't need to do anything. Theta prime is this angle in here. So in quadrant 4,
Quadrant 4 is
it is 2 pi minus theta. So I'm going to do 8 pi over 4 so that I have the common denominator minus 7 pi over 4. So theta prime is pi over 4. Which again, kind of just logically makes sense.
It does.
oh yeah, that's on the
All right. You're going to want your unit circle handy for these next few questions. So evaluate without using a calculator.
Why can't I be using a calculator sometimes?
Really wouldn't have helped you, but
yeah, calculator.
secant of 135 degrees. So remember, we think about secant in terms of cosine. It's 1 over the cosine of 135 degrees. So what is the cosine of 135 degrees?
Cosine of 135 is
Cosine.
negative square root of 3 over 2. No, negative.
Negative root 2 over 2.
Negative root 2 over 2. So this is 1 over negative root 2 over 2. Keep change flip gives me negative 2 over root 2. And I'm being excessive writing out every little thing. You don't have to do it this way. Rationalize it. I get negative 2 root 2 over 2, which gives me negative root 2 simplified.
That's weird having fractions, sign fractions. Well,
I did it.
how did we go from the 1 over the fraction equals negative 2 over square root of 2 again?
So you go to 135 on your unit circle,
Yeah, which is actually
and
our
you need the
120,
the secant,
which is the x,
right? No, it says you need the cosine,
which is this one.
right?
Yeah,
And the cosine is the x value.
And that's
So you go to that ordered pair,
yeah,
and you pick the first one because the first one is x.
Yeah.
The first one is negative root 2 over 2.
yeah.
So then you put that under the 1.
Yeah, and then how did you go from that to negative 2 over square root of 2?
Keep, change, flip.
Yeah, because
What is keep change flip?
A multiplication
because
process.
secant is the
Divide by a
flip
fraction,
version.
multiply by the reciprocal, keep change flip.
And that's only if you have a fraction and a fraction.
No, that's how you divide fractions.
I literally have no
That's
idea.
how you've always and forever divided fractions.
I haven't divided fractions in a year and I don't know what I'm doing. So keep the bottom one, change the bottom one, flip it.
No.
KFC. I'm in.
Keep the top fraction,
Keep the top so 1, 2.
change the bottom one,
So 1.
or change the sign and then flip it. So instead of it being dividing, you're now multiplying.
So
It's
1 times 2 over square root of 2. Right there. Look.
Keep, change the sign, flip.
because instead of dividing,
Hi, bathroom.
I have like 3 questions left, but if you really need to go, you can. I'm just saying, I don't care, but 26, the sine of negative 150 degrees. So you got to count backwards now. So back that many. So from 360 back to 270 is negative 90. And then I need to go 60 more degrees, which puts you where?
Okay. Neg good 210.
Yep, so this would be the equivalent. You can either do this by coterminal angles or by counting backwards as the sine of 210 degrees. What is that?
Negative 1/2.
Negative 1/2.
Sine is I have to find the coterminal because it's negative.
So keep change flip.
Well, you don't have to find the coterminal. That was just a different way to think about it.
But it'd be the same if I didn't.
Yes.
Getting
Negative 150 and 210 are the same thing.
Yeah, I figured it.
All right, 29. I know it's an odd one, but it is a very odd problem, so I want us to talk about it.
Oh man. it
All right,
was
cotangent of negative 8 pi over 3. All right, so on the unit circle, okay, we're going, what was it, 8 pi. All right, so we're going all the way around. One time backwards is 6 pi over 3. So that's 2 pi. Then I need to go 2 more pi over 3s. So this is 7 pi over 3, 8 pi over 3. Okay, so that would be the equivalent of 4 pi over 3 in the positive direction. So this would be the same as the cotangent of 4 pi over 3. Could do that with coterminal angles or by counting. I like the counting method, less math involved. So cotangent we think about in terms of tangent. So this is 1 over the tangent of 4 pi over 3. What's the tangent of 4 pi over 3?
Root 3.
Root 3. So this is 1 over root 3, which rationalizes to root 3 over 3. All right, any questions on that?
You didn't have to keep change flip at all.
All right, problems, which you will have tomorrow in class to do after you take your unit circle quiz. 3, 5, 7, 15, 17, 19, 23, 25, 31.
Do you remember that?